The Big Bang, the idea that the universe was suddenly born and not infinite. Long ago, in the early 1900s, people believed the universe stayed the same. However, in the 1920s, George Lemaître proposed an expanded universe. In the 1930s, Edward Hubble saw the proof. In the late 1940s, Fred Hoyle invented the term the Big Bang. And then, in the 1964, Penzias and Wilson discovered cosmic microwave background radiation. Since then, the Big Bang theory has been confirmed. The Big Bang theory explains its scientific explanation for the origin of the universe. It suggests that the universe began as a tiny, infinite, hot and dense point, approximately 13.8 billion years ago. This theory is supported by a significant body of evidence, including the cosmic microwave background radiation, the distribution of galaxies and the redshifts, and the abundance of light elements in the universe. The Big Bang theory has been a foundation of modern cosmology and has been widely accepted within the scientific community. After the Big Bang, 5 major events occurred. Within 1 to 10 seconds, the universe cooled down. Lots of lepton particles and opposite bumped into each other and vanished, leaving a few extra leptons, balancing out the photons. Neutrinos stopped interacting with each other, particles, making the universe transparent. After the initial phase, around 10 seconds after the Big Bang, the universe was mostly filled with light particles called photons. These photons kept interacting with protons, electrons, and later with atomic nuclei. This continued for a very long time, approximately 300,000 years, which we call the radiation era. Between 3 to 20 minutes after the Big Bang, the universe cooled down further, allowing protons and neutrons to stick together and form helium and deuterium nuclei. The process is known as nuclear synthesis. This used up all the extra neutrons. However, the universe became too cool and sparse for the fusion to continue. Around 380,000 years after the Big Bang, hydrogen and helium nuclei captured electrons, forming stable atoms of neutral charge. This made the universe clear for light to travel through. These ancient light particles are still detectable today as a cosmic microwave background radiation. About 1 billion years after the Big Bang, the first stars and galaxies began taking shape, with stars emerging around 100 to 200 million years after the Big Bang, followed by the formation of galaxies about 1 billion years after. During this time, heavy elements were produced through powerful supernova explosions.
Before the Big Bang theory, there were many scientific theories are accepted, include the steady-state theory, oscillating universe, plasma cosmology, the tree-like hypothesis, the steady-state plasma theory.
Long ago, people had philosophical and religious ideas, but later the Big Bang theory became widely accepted in the 20th century because of evidence like cosmic radiation and redshift. This theory got refined by the idea of inflation, expanding, rapid expansion, and more recent thoughts about multiple universes. All these changes happened because of the technology advancements. Telescopes such as the Hubble Space Telescope can see distant galaxies and cosmic events clearly, providing important evidence for the Big Bang theory and early universe phenomena like cosmic microwave background radiation. Particle accelerators allow scientists to recreate the conditions of the early universe, helping them understand how particles and matter formed. Sophisticated computer simulations also help scientists make simulations to test their theories, making it easier to understand how the universe has evolved.
Alright, so in 1927, George Lemaître first proposed that the universe began as a single point of concentrated matter. He called this the primeval atom. This atom later exploded, scattering matter which formed galaxies, and expansion continues today. Lemaître's theory helped explain Hubble's discovery that the universe was expanding. The other major contributor was of course Edward Hubble. In the 1920s, he was studying distant galaxies through large telescopes, and he discovered that the further away a galaxy was, the faster it seemed moving away from us. This allowed him to conclude that the universe must be expanding over increments. Through this, Hubble and Lemaître's work established the Big Bang theory as the leading explanation for the origin and evolution of the universe.
Redshift of light. When we look at the light coming from distant galaxies, we see that it's often shifted towards the the redshift of the color spectrum. This is called redshift. It happens because the galaxies are moving away from us. This supports the Big Bang Theory because it suggests that the universe is expanding. As the greater the redshift, the faster it is moving away. Just like when you blow up a balloon and all of the dots move away from each other, hence allowing the calculation of the age of the universe. Cosmic background microwave radiation. Scientists have discovered a faint glow of microwave radiation that exists everywhere in the universe. This is like a leftover heat from the early stages of the universe. This supports the Big Bang Theory because it shows that the universe was once very hot and has been cooling down as it expands, hence allowing the calculation of the age of the universe. The Big Bang Theory predicts that certain elements like hydrogen and helium should be more abundant in the universe compared to the other elements. When scientists observe the universe, they find that the abundance of these elements matches what the Big Bang Theory predicts. This supports the theory because it shows that the early universe went through a process where these elements were formed. Just like when you follow a recipe and then end up with the right amount of ingredients in your cake.
The cosmic background microwave radiation is one of the strongest proofs for the Big Bang Theory. Scientists collected data using the Kolbe-Planck satellite experiments, which provided consistent and reliable measurements of radiation's temperature and isotopy. The data supported the Big Bang Theory's predictions about the radiation properties, such as a specific type of spectrum and even distribution. Because of this strong evidence, we can be confident about the Big Bang Theory's explanation and how the universe began and evolved.